Greetings, students. In this video, we're going to look at writing equations of lines given 2 points on the line. Okay, so we know from back in chapter 3 and from before that whenever we write the equation of a line, it's always in this y equals mx plus b form. We always need the slope, and we always need the y-intercept. Okay, and we know that slope and growth mean the same thing, and y-intercept and starting amount mean the same thing. So once we have these two things, once we're able to identify or find these two things, our slope and our starting amount, we could write the equation in our y equals mx plus b form. So we're going to start with another word problem, or with a word problem, to help us kind of build a conceptual understanding of what we need to do. So it says Herman has a job mowing lawns to save up to buy new shoes. After mowing 5 lawns, he had $115. After mowing 8 lawns, he had $175, and he charges the same amount of money per lawn. So we want to write an equation. So press pause, take a moment to finish copying this down, then press play when you're ready to work through it. So we see the directions to write an equation. So whenever we see those directions to write the equation of a line, okay, that's what we're doing here. We're writing the equation of this line, and we know it's a line because he's earning money. We have some sort of growth, okay, even though it doesn't necessarily tell us directly. When you read an equation and you realize that there's something is growing, something is changing or increasing or decreasing, we want to write the equation of a line. That's what this situation is. Okay, he's saving money. Saving money is a concept where something's growing, so we want to write the equation of a line. And when we're writing the equation of a line, we need the slope, or the growth, or the y-intercept. So this is what we need to identify. What is our slope, and what is our starting amount? Okay, how much money did he have to start with? And how much money does he get per job? The slope in this situation would be how much money he gets per job, and the starting amount in this situation would be how much money did he have really before he started working. So when we read this problem, okay, it doesn't tell us directly how much money he gets per job. So we don't know the slope, and it also doesn't tell us how much money he had before he started mowing, after mowing 0 lawns. We don't know the starting amount. So in order to write the equation in this case, okay, we need to find these two things first. Now, luckily, these are two things that we already know how to do. We're able to find the slope given a word problem. We're also able to find the starting amount kind of given some information in the problem. So let's start with finding the slope again. So we want to know how much money does he get per job. So we know after mowing 5 lawns, he has $115, and after mowing 8 lawns, he had $175. We need to figure out what is our delta y. How much total money is he getting? So whenever it says find the slope, it doesn't give us directly. We need our delta y and our delta x. Delta y in this case is how much money did he get? Well, if he went from $115 to $175, that means he earned $60. So he got $60. Now we want to know how frequently did he get this $50? How many lawns did he have to mow in order to get this $60? That tells us our delta x. What is our delta x? Does he get $60 every lawn? Does he get $60 every 2 lawns, every 3 lawns, every 4 lawns, or what? What is our delta x in this case? Well, he mowed 5 lawns, and then he mowed 8 lawns. So 5 is 115, 8 is 175. So to get from 5 lawns to 8 lawns, he mowed 3. So he got $60 every 3 lawns. Okay, that's his slope. So we use this to figure out his slope. That's his rate of change. He gets $60 every 3 lawns. That's the information in this problem tells us. Now, if you need more practice finding the slope, then go back and watch one of the earlier videos where it says finding slope given word problems. So we know our slope is our change in y over our change in x, and we reduce it to get 20. Okay, this is he gets $20 per lawn. Okay, so that's his slope. The slope is 20. He gets $20 per lawn. So we want to know now, what is his starting amount? Well, this 5 lawns is $115. Well, that's really a point on this line. He mowed 5 lawns, and he now has $115. So that's like having the point 5,115. Okay, so now that we have the slope and a point, we know how to find the slope or how to write the equation of a line given this information. If we know the slope at any point on the line, we're able to write the equation, because we know we would do our slope here. It's $20 per lawn, and he mowed 5 lawns. So mowing 5 lawns, if he gets $20 per lawn for 5 lawns, it means he made $100. So if he made $100, what did he have to start with so that he now has $115? So he made $100 plus what he started with is his $115 total dollars that he has after mowing those 5 lawns. So this B equals 15. So his starting amount is 15, meaning he had $15 before we started working. And we get his equation is y equals 20x plus 15. And then just to check our work, we see that we also have this other point. After 8 lawns, he had $175. So you could ask, well, why do we use this 5,115 and not the other point, 8,175? Okay, that's a good question. Okay, it really doesn't make a difference what point you use because he's getting the same amount of money each time. If you do 20 times 8, okay, this is just a check. If we do 20 times 8, this is $160. Okay, so we know 160. Well, we're saying he started with 15, so if we do 160 plus this 15, we should get the 175, and we do. Okay, this is true. 160 plus 15 equals 175. Okay, and that's exactly what we got before. Okay, he started with these $15. We figured out he started with $15, so if we use this point, we should get the same thing, and we do. 20 times 8 is 160. 160 plus 15 is the 175 we want, so we know for sure that this is the equation. He gets $20 per job, which we figured out from the problem, and he started with $15, which we figured out right here. Okay, so that's just our general process. The very first thing we needed to do was figure out what's our slope. Okay, how much money did he get per lawn? Then we use that slope and the information in the problem to figure out the starting amount, because once we have the slope and the starting amount, we're able to write the equations. That's our whole process. In problems like this, where it gives us 2 points on the line, well, we still need the slope and the starting amount. Whenever it says write the equation of a line, you have to identify the slope and the starting amount. And once you identify the slope and the starting amount, it's very easy. The only difference in this problem than the type 4 is we weren't given the slope. We had to figure out the slope. Okay, so we're going to jump right into our algebraic examples. Okay, because the whole concept behind this is the same as before. We understand what slope is, we understand what the starting amount is, so we're able to just look at and focus on the strictly algebraic examples. So let's say we're writing the equation of the line. Those are the directions for all these problems that go through the point 3, 9 and 4, 11. So we want to write the equation of this line through these 2 points. Okay, so we can think of this as figure 3 has 9 tiles, figure 4 has 11 tiles. Okay, you had, after 3 days you had $9, after 4 days you had $11. However you want to think through this, we know lines represent situations, so we always use situations to help us build a conceptual understanding of what we're doing to make the algebra easier. Okay, so we want to write this equation of the line. Okay, so we need the slope and our starting amount, which we should really start calling our y-intercept. Okay, do we know our slope? No, it doesn't tell us our slope. Do we know our starting amount yet? No, it does not tell us our starting amount. Okay, we don't know how many tiles were in figure 0, and we don't directly know how many tiles we're adding each time. So we need to figure out our slope, and we're just going to do this quickly because this was a lesson from another day in another video. So we need to figure out the slope. How many tiles are we adding each time? Well, figure 3 has 9 tiles and figure 4 has 11 tiles. Well, to get from, this is just going to the next figure, so our slope is just 2. Okay, we're adding 2 tiles to get from figure 3 to figure 4. Okay, because 9 plus 2 is 11. We're adding 2 tiles each time. Okay, our delta y is 2 and our delta x is 1. So what's our starting amount? So we need to use this slope now to figure out our starting amount in one of these points. I'm just going to choose the first point. It doesn't make a difference. We'll check with the other point to get in that good habit. So we know we're adding 2 tiles each time. and we're getting to figure 3. So we have to do 2 times 3 plus the number of tiles in figure 0 plus what we started with has to get us 9. Okay, so we added 2 tiles 3 times, means we added 6 tiles. So what did we add 6 tiles to? So we have 6 plus b equals 9, which means b equals 3, because 6 plus 3 equals 9. So we know our slope is 2 and our starting amount is 3. I know I worked through this quickly because, again, this is something we know how to do. We know how to find the slope, and then once we have the slope, we know how to use the slope and a point to find the starting amount to write the equation of the line. Okay, writing the equation through 2 points just kind of combines some of the skills we already know how to do. So we have y equals 2x plus 3. What I'm going to do is I'm going to check it with my other point, 411. Okay, this means if I use this rule, this equation with this point, it should also be true. So if I do 2 times 4, okay, if I want to get to figure 4, I have to add 2 tiles 4 times. So 2 times 4 is 8. Is 8 plus 3 11? Of course it is. Okay, so we know for sure that this is correct. Okay, this point, or this rule, also makes this point true. It's a way to check our answer. Okay, let's try another one. Say we have the point 519 and 1018. And we want to write the equation of the line through these 2 points. So again, we need our slope and we need our y-intercept, which is our starting amount, but we're just going to start calling it the y-intercept. Okay, we know how to find the slope. We need our delta y and our delta x. Our delta y is, well, we're going from 19 tiles to 18 tiles. That means we subtract 1 tile. And our delta x is how frequently are we subtracting these 1 tiles? Well, we're going from figure 5 to figure 10. So we're subtracting 1 tile every 5 figures, so our slope is negative 1/5. Again, it helps if you could also picture these points plotted. If you're able to visualize a graph, this makes this whole process very easy. We have the point 519, we have the point 1018. Okay, so this point is 1 lower, but it's over to the right. Our delta y is 1 because we have y equals 19 and y equals 18. So our delta y is negative 1. We have to subtract 1 tile, and we're going from figure 4 to figure 10. Or sorry, figure 5 to figure 10. So our delta x is 5. Okay, we're going down 1 and over 5 to get from this point to this point. So our slope is negative 1/5. Okay, that's half the battle, but we still need our y-intercept. But this process doesn't change. We have our slope and we have our point. Now we just use this information to figure out our y-intercept. If we're subtracting 1 tile every 5 figures, how do we get from, what do we have to start with to get to 519? If we go down 1 over 5 to get to the point 519, what do we have to start with? Well, I mean, you could think through it logically if you're able to visualize, or we have to go through our process. We have negative 1/5. We're subtracting 1 tile every 5 figures to get to figure 5. So we do negative 1/5 times 5, just like we did before. Plus what? Gets us the 19 that we want. So negative 1/5 times 5 is negative 1. So we're subtracting 1. So what do we have to subtract 1 from? 20. Negative 1 plus 20 equals 19. Okay, and if we are able to picture this, we have to start at 20 because we go down 1 to 19 and over 5 to get to 5. So our y-intercept is 20. So our equation is y equals negative 1/5 x plus 20. Now we're going to check with the point 1018. So that means if we do negative 1/5 times 10 plus 20, we better get 18. So if we were to substitute negative 1/5 times 10 plus our b value, do we get this 18 that we want? If we would have used this point to figure out our b, will be got the same thing. Well, negative 1/5 times 10 is negative 2. Okay, negative 2 plus 20 is 18. Okay, it's exactly what we want. Negative 2 plus 20 is 18. So we know for sure that's correct. Again, this is just to check it. All we do to check is we just substitute 10 in for x, negative 1/5 times 10 plus 20, and we better get 18 out for y. We're just saying, is this point on the line? And that's what we want, because the line went through these 2 points, so this point better also be on the line. Okay, we'll do one more together. We want to write the equation line through the point 8, negative 13. and -1, -4. Okay, just because we see negatives doesn't make us afraid. We still know that we need our slope and we need our y-intercept. And even though it's harder to kind of think through these conceptually with a concrete example, since we understood what these figure means of finding the slope and using the point to find the starting amount, it's okay. We're able to deal with and handle the algebra with our negatives. So we need our slope. So we're going from figure -1 to figure 8. So what's our delta y? Well, if we're going from -4 tiles to -13 tiles, if we're going from -4 tiles and we're going all the way down to -13 tiles, that means we have to subtract 9 tiles. Okay, again, if you need more practice finding slope, then you have to refer to one of the earlier videos. So I expect you know how to do it at this point. Now we're going from figure -1 to figure 8. That means our delta x is 9. We're subtracting 9 tiles every 9 figures. So our slope is -9/9, which equals -1. So we're subtracting 1 tile each time. Now we don't know the y-intercept, so we need to figure out our y-intercept. So if we do -1 times 8 plus what gets us our -13. -1 times 8 is -8. So -8 plus what or minus what equals -13. So b equals -5. We just add 8 to both sides, and -13 plus 8 is -5. We're just solving for b. So our equation's y equals -x minus 5. And we're going to check with our other point just to make sure we did it right. So we take the opposite of x minus 5. The opposite of -1 is +1, minus 5, and we hope that this equals 4. 1 minus 5, or sorry, -4, 1 minus 5 does equal -4. So we're happy because we did this problem correct. Again, this point better be on the line, and if this point's on the line, then it better make this equation true. Okay, so why don't you try these examples. So when you see them all, press pause, give them a shot, then press play when you're ready to check. Okay, so we're writing the equation of the line through these points, and these points. Okay, our first example, we need the slope. The slope equals 5. And we need to use this to find our y-intercept. So we do 5 times 2 plus what equals 10. We just solve for b. We realize that b equals 0. So our equation's y equals 5x plus 0, but it's silly to write that plus 0. So our equation's y equals 5x. We check with the other point. 5 times 3 is 15, so we know we did it right. Okay, this one, we're subtracting 1 tile. Our delta y is -1. Our delta x is 2, so our slope is -1/2. So we use this, -1/2 times 6 plus b gets us 9. -1/2 times 6 is -3. We keep solving for b, we get b equals 12. So this equation's y equals -1/2 x plus 12. And we check with our other point. -1/2 times 8 is -4. -4 plus 12 is 8. That's exactly what we want. This point's also on this line. So we know we did it right. And our last one, we're going from figure -4 to figure 1. So we go from 0 to -15, so our delta y is -15. Our delta x is +5, so our slope is -15 divided by 5, which is -3. So you do -3 times -4 plus b equals 0. -3 times -4 is +12. 12 plus what equals 0? That means b equals -12. So our equation's y equals -3x minus 12. Check with the other point. -3 times 1 is -3. -3 minus 12 is -15. That's exactly what we want. This point is also on this line. So So these are the answers. So if you need more practice, still refer to some of the other online resources or the textbook.